Welcome to a lesson with Dr. Powell. Let's talk about how we can find the centroid of a triangular region with with a calculation. So we'll show the result and then we can use it after we show it. Um, so let's suppose that we have a triangle like this, um, and so kind of like, even if we had a triangle that looks something like um, this, we can use the same process because you notice that your little changes of M or changes of A, whether can all like if you're in this case, you can kind of like use a principle and kind of shift all your rectangles upward to kind of flatten the triangle into this form. So we can really, it suffices just for simplicity and calculation's sake. If we're thinking about a triangle where we have a particular height of a triangle that comes to a point from a base, and we're going at a 90-degree angle up from it, up this way, up to the pinnacle peak, we can, it suffices just to consider this case. And the centroid calculation that we make here actually can be applicable to all triangles if we're thinking about our coordinate as being perpendicular from the base itself. So that's also something to keep in mind. Okay, so that's the type of thing that we're going to be working with. So it suffices to just consider a case like this. Now, in general, we might not know what the slope is, so let's just say it's y is equal to kx here for this particular line. And let's suppose that we're going from 0 up until h, where h can be considered to be like the height of the triangle from a base here, and then we go up this way. How long is that distance? We'll call that h. So we'll kind of have that in mind as well as we go along. Um, okay, so let's make the computation. In making this computation, we'll need to know what the total area is. So we're computing centroid of this region. The total area of this region, well, we need to know what the base right here is just h, and the actual height here. So this height is referring to something else, that h, but the height of this actual triangle we get by plugging in this value for x into here, which should we get kh out. So we have a height of kh times h and then divided by 2. So we get kh times h divided by 2. So kh squared over 2 should be the area. So we'll need that in our integral. 1 over that would be the reciprocal, so 2 over kh squared we'll need. Now our integral is going to be from 0 to h. And let's first consider, let's just try to compute x bar. So what do we need? We need to have x in here, okay, finding average value of x, and then we need a dm. So at a particular x value, what is our dm? So we draw a little rectangle and we think, well, dm will have a dx, right? Because the dx is the width. And what's the height though? The height is going to be, well, what's the y value here is kx, and the y value here is 0. Subtract kx minus 0 gets to kx. So we're going to get kx right there. So that's your dm. All right, so now we can make the computation. This right here is the same as kx squared. So when we integrate, we're going to get, so this constant, 2 over kh squared, and then times k times x cubed over 3. And then we evaluate this as we go from 0 to h. Now, as we go from 0 to h, let's see what happens. 0 is just 0 at h, we put an h. So this is really just going to be this 2 over kh squared times k times h cubed all over 3. Notice that that cancels with, okay, so we just left with an h on the top, the k's cancel, and we get this amazing thing, 2/3 times h. which means that the center, that if we go from the peak this way, we're going to be 2/3 from the peak into the shape this way to get to x bar for any triangle. 2/3 into the shape, which means it's 1/3 into the shape or into the triangle from the base. So 1/3 of the height up from the base. So 1/3 of height from base is is the centroid of a triangle. Now we can actually compute y bar this way because we also have a triangle going up like this from the base, and so we actually y bar is going to be 1/3 up from this base. So we're 1/3 from this base, we're 1/3 from this base, and we can, by symmetry, you can reuse that. So we can look at a specific example. If we have for instance, let's just take a triangle of that basic sort and compute x bar, y bar. So let's suppose that we have, well, and just coordinate, let's just make coordinates here. Suppose this is a coordinate of 0 to a coordinate of 4. This is a coordinate of 0 to coordinate of 3, say, okay? And where is x bar, y bar? Well, so this tells us that x bar is going to be this way, so 1/3 in, so 2/3, so which is a 2/3 of the total 4 because it's 1/3 this way. So 2/3 times 4, so it'd be at 8/3, which is the same as 2 and 2/3, or 2.6 repeating, if you will. So 2.6 repeating will have the x bar here, and that's because this is 1/3 of the way into the shape from 4, which is the same as 2/3 of the way this way. So we just took 2/3 times 4 to get that. Here we're going to get 1/3 of the way up here, which should be very simple. What's 1/3 of 3? It's 1. So actually the centroid of this shape is 2.6 bar repeating, comma 1. Okay, so we're going to be 1 up because it's 1/3 of the way up that way. So this is just a little example how we can use this. Now, even if we can use this in the following case as well, what if we had just any old triangle, and let's suppose that we just knew what the height was of this triangle from the base. So what's the height up from the base perpendicularly? So we think of this as, and let's suppose, for instance, that we knew the height was 6. Then we actually will know what y bar is, assuming that this is vertical going up this way. And assuming this is the y value of 0, then y bar will simply be 1/3 of the way up. So it'll be 2. So we know that automatically for a triangle based upon our original computation. Now, compute x bar would be a little bit more tricky since we don't really have a base to work off of here. But what we can do, we can do something, and we'll illustrate that in another video. That is, we make 2 triangles, and we find the centroids of this one, the centroid of this one, and then we take a weighted average of those 2 to get the the actual x bar. So that's also possible, and we'll show that in another video. Thanks for watching.